few words about myself. I've been a .NET developer for 8 years now. I'm Iulia Dormenco, in case some people don't know me. I've been working with AWS for the past year, and I've really grown to enjoy it, let's say. And today I'm hoping to give you sort of a nice little sort of overview of how to build, deploy, and host REST APIs in the AWS environment using, of course, .NET Core. Okay, let's get started then. I think we're all pretty comfortable with the idea of having .NET Core applications and .NET in general running on Azure. Of course, it's under the same big umbrella of Microsoft, and it just seems right, you know. But maybe you wouldn't think that it's actually very possible, and it can work very well to have .NET Core applications running under AWS. They actually have a lot of tools and support for that, including an SDK, a CDK, and all sorts of other great tools. And today we're going to be exploring one of the ways in which these two tech giants can work together, basically. Okay, a little disclaimer. I'm going to be talking and going through quite a few different AWS components tonight. It's not sponsored, but unfortunately, I'm not going to be able to go into very much depth into all of them in just 1 hour. My hope is that I'm going to be able to give you enough context and enough details to sort of get you started. And you will have a repo with both the demo and the slides available at the end of the presentation. But yeah, forgive me if I'm not going to be able to go into so much detail with each of the AWS services we're mentioning tonight. I was chatting to a colleague yesterday, and we counted there were like 7 different services that we're going to be touching. So an hour is just a little bit too little time for that. Okay, first things first, we want to build a REST API. How would we do that? You know, first thing we would like to achieve is, okay, let's have a new project. How does one create a new project that's going to be runnable on AWS easily? Well, AWS were kind enough to create a toolkit for Visual Studio 2017 and 2019. There are also versions for older sort of versions of Visual Studio available. So I think it goes back to about 2013 and potentially even earlier than that. And what this toolkit provides is a series of project templates that make it very easy to set up a REST API that will then be easily deployed on AWS infrastructure, but also sort of some explorers to help you see various resources in your AWS account, and also the ability to actually deploy to your particular AWS account, sort of in a more play project, sort of my developer project sort of thing. And we'll actually see that in the demo later on. Okay, so we have a new project. Cool. Let's call it AWS REST demo. And we're gonna start to notice something's not quite what I expected it to be in sort of a usual REST API project that you would create just in .NET Core. So what are all these weird files here? Well, let's have a bit of an overview, shall we? You can see that there are 2 different entry points, a Lambda entry point and a local entry point. And these will be the files that we use to actually run the API in 2 different environments, locally and of course on AWS. That's the whole point. We also have the serverless template, which is where we specify the resources that will need to be created for our REST API to work. And also a Lambda tools default, which is used by the AWS toolkit to save parameters used in the deployment process. And we'll look at that in a bit more detail later on. Okay, the big difference and sort of the most important thing that you need to have in a REST API project that you want deployed on AWS is basically the Lambda entry point. This helps you bootstrap the ASP.NET Core framework, so it will actually run on AWS. And as you can see, there's not a whole lot of coding that you need to do up front. The important thing to notice here is that the Lambda entry point actually derives from an API gateway proxy function. And this base class, if you drill down enough in the hierarchy, actually contains the function handler that will actually be called, that will run your code eventually, as we shall see. But out of the gate, there's not a whole lot of things that you need to do to get this running in the first place. And also in that function handler, you do have the opportunity to extend it and override some of the basic functionality there. If you want something like custom logging, or if you want to sort of plug into other life cycles of the Lambda function, stuff like that. But yeah, initially, there's not a whole lot that you need to do here. And of course, it uses just the same old startup that you would use in a regular ASP.NET Core application. Okay. Moving on to the other local entry point. We can see here, I've put them side by side with the regular program class that you saw was completely missing from our project, but they are essentially identical. And the point of having the local entry point is to be able to run your function locally and your API locally in Kestrel, like you would any other API, basically. Okay, in terms of serverless template, the serverless template that comes with the basic project is a SAM template. A bit of background here, there are sort of at least two ways of writing templates for AWS resources. The basic and quite verbose one is AWS CloudFormation. And the sort of friendlier, more developer-oriented one is AWS SAM, Serverless Application Model. And what SAM does is it both allows you to write templates that are a little less verbose, so it would allow you to not specify every single thing that you would need in the template, but it also gives you a set of tools to deploy and get your package ready and uploaded in the AWS environment, as we'll see later on. In the project, as we'll see, this is in JSON format, and during the deployment process, all of it gets transformed to YAML. Luckily, JSON, in my point of view, is a little bit friendlier to use, so I'm happy that it's JSON. Personal preference here. Okay, let's look at sort of the basics of a SAM template. Okay, so as you can see here, I've minimized some of the resources so you can see an overview. But basically, the elements here are the transform that says that this is a transform over a CloudFormation template. Of course, description stuff. There is an area where we can specify parameters that we would like to give to the serverless template, and these can be used in the resources and later on in the template. And there's also a section for output. So if you want to create a URL, or if you want to output certain variables or things from your stack, you can do so in the output section. And if we look at the resources bit in a bit more detail, we can see here that for our project, we only have one resource declared, which is for the ASP.NET Core function. And what's interesting is it's a type serverless function, which essentially is Lambda, basically. And you can see here that the handler specifies the Lambda entry point function handler async, which wasn't present in the class itself, but it was present on the base class that the Lambda entry point actually derives from, as stated previously. The code URI is basically going to point after we deploy in package and everything. It's going to point to where the deployment package resides on an S3 bucket, as we'll see later on. And we can also specify some memory and timeouts here, as well as access policies to sort of be able to run our function. The interesting bit here with events is basically stating how our Lambda function will be triggered. A Lambda function by itself doesn't do a whole lot unless it gets triggered somehow, either by a schedule, by an SQS message, by an API gateway request, and many other services basically in the AWS ecosystem. And in this case, what these events will amount to is an API gateway trigger. So whenever we get a request on our API gateway, the Lambda will be triggered and it will get resolved. Okay, so some considerations. Essentially, for each request that we'll get on our API, we'll be creating a new instance of the Lambda, and that instance will handle the request. That does mean that we need to think about sort of memory allocation and how long that function will be able to keep running, so in terms of timeout. By default, the memory allocation is pretty low. It's only 128 megabytes. And the default timeout is 3 seconds, but these can go up to almost 3 meg in 64 megabytes increment, 3 gigs, sorry, my bad. And the maximum timeout here is 15 minutes. Of course, maybe you would like to not go to the maximum timeout if you can avoid it, but sometimes you just need that sort of leeway. So that's just something to keep in mind when you're actually building a real API in the real world. Okay, so we've built our API project. Say it's nothing very fancy. We have all the components going on. Let's start thinking about deploying. And in order to deploy, of course, we're going to need to create a deployment package. And what's the first thing that you would think of for a deployment package? Well, .NET Publish, that's what we do in .NET Core. But is that going to be enough to create everything that AWS needs? Well, turns out AWS needs, of course, the compiled assembly, the dependencies and everything, but it also requires 2 additional files, a project dependencies JSON and a project runtime config JSON. And these don't get created by default if you just run .NET Publish. You're going to need to specify some additional arguments, one of them being the generate runtime configuration file. And also you would need to specify the runtime in that command line as well. But in order to make our lives as developers easier, what AWS has done, and we thank them for it, is packed all those commands and parameters into a nice little global tool, which will allow you to deploy a Lambda from your local environment. And you can install this from the .NET CLI with a simple .NET tool install. And the command to deploy it is just .NET Lambda deploy serverless. Very simple. We'll look at that in just a second later on. The interesting thing about the deploy Lambda deploy serverless is that in the background, it actually still calls the .NET Publish command, as we'll see. But it also specifies this generate runtime config, the runtime, and a couple more configurations there to be specified. So essentially, it's just a nice wrapper that we can use without having to think about and remember all the other command parameters, which is nice. Of course, you don't always want to deploy only from your local machine. Sometimes you have a CI/CD pipeline like TeamCity or Jenkins, maybe even Azure DevOps. You can actually deploy stuff to AWS from Azure DevOps, which is cool. And in that case, after you've created a deployment package, you can use SAM commands to actually package and deploy that particular package, or just use the simple SAM deploy command to the same effect. It's been recently upgraded. So those are sort of the big options. And also, as stated, you can use the toolkit from Visual Studio to deploy, but again, that's more of a developer option, so to speak. So that being said, let's exit this nice little presentation and start deploying our API. So this is the REST API that we've been looking at so far. You'll see that the functionality in the API itself is very dumb. It's just the regular template for users to prove that it works, because the point of the presentation wasn't necessarily about that functionality. So we have this already set up, and what I'm going to do now is actually run the deploy command, and let's see what happens to it. Deploy serverless. So what you'll see here is the first thing it asks for is the stack name for CloudFormation. Essentially, CloudFormation stack is a way of grouping your resources, so you know that they all go together. And if you need to sort of delete or update it, you're going to know you're hitting the appropriate resources. You don't have to spend time figuring out, okay, I have 300 Lambdas in my AWS account, which is the appropriate one for this application. And you'll also see that we also get prompted for an S3 bucket, which I'm going to find right now. And the purpose of the S3 bucket is to have a place where to upload our package. And from there, AWS and CloudFormation, respectively, are going to use our package to create the stack, create the resources that we need. As you can see, the publish command has started. We're zipping the deployment package, and we're actually uploading to S3. And we've started creating the CloudFormation stack. And I can actually show you. So this is my personal account in the Ireland region, because it's rather close to Romania, more or less. And you can see that my stack has begun creating. We can see here the events as they start to come in. We're gonna get nice feedback, and this is the point in time where you start praying that the demo gods will hear you and everything will go smoothly, even though you've rehearsed it like 500 times. But you know, it helps. It helps to pray a little bit. Okie dokie. So our stack has created. Let's take a look over the resources that we have here. Remember that in the template, we only had one resource specified, the function. But when we take a look here, we see that there's actually a whole bunch of other things that have been generated for us. So of course, the first one is the Lambda function that we specified. There's some permissions and a function role that gets created for us. But there's also a API gateway, deployment for that gateway, and a particular stage for that gateway. I'm not going to go into too much detail about that one, but that's kind of what it is. So let's go and look here at our API gateway. So we can see here it's generated with root and a proxy. And if we go to sort of explore what's on this. Sorry, my headphones have the ability to self-close if they don't hear sound for a little while, so bear with me here. I might have to do that a couple times during the presentation. Okay, so what we can see here is if we explore in the API gateway div that we've created, you can see that we have sort of the gateway itself. We see that we can have a method request, and essentially the gateway is simply a proxy to our Lambda in this case. All the requests will flow through to the Lambda that we've created inside of the stack, which is exactly the same one. And the response from the Lambda will get outputted to the API gateway as is. So there's also the option of sort of setting up transformations if you're just doing an HTTP or a REST API gateway with regular methods and endpoints. But how the Lambda functions and API gateway function together in the case of .NET Core REST APIs is that they just act as a proxy, sort of. Because the Lambda in itself is just a function running somewhere inside of AWS, it's not really exposed in any way to the internet. So you would need some sort of way to get your clients to have an endpoint that they can call. And that's exactly what the API gateway does. And I also wanted to show you on the API and on the stack, essentially, is that we output this lovely URL, which is generated by AWS, which actually points to the API gateway that we have here. If you'll notice, it starts kind of with the same letters, TWK something, or yeah. And let's go access our Lambda, our API, sorry. And we can see that it's up and running. We can give it a little test, even though it's not a very smart API. But we can see, okay, everything's up and running, working nicely. Great. Before we move it on from this, though, I would like to also show you in S3 sort of what our where our package actually goes, because it is quite interesting. So we can also see here the template as it's been transformed. And I mentioned previously the code URI property on the function resource. And previously it was just an empty string. But as you can see during the deployment process, what happened is that the deployment package gets uploaded to S3 on this URL. And the template is actually transformed to point to this particular code URI. If you're doing deployment sort of in a more CI/CD fashion, you would actually specify here the name of the zip files that you output from your build, essentially. Okay, and if I go to S3 and show you the actual bucket, you can see that there's a whole lot of paths here, and I believe sort of the path was ASP.NET Core code URI something something. You can just search for it directly. So you can see that it's uploaded here and we've just previously used it. It's just so you can get a feel for where our deployment package goes in this whole shebang. Okay, so we've looked at sort of what happens to our packages. We've seen the resources generated. Everything's working fine and dandy. But now we get this very ugly URL that gets generated for the API gateway. And this is, of course, because we didn't necessarily tell the API gateway to generate anything nicer. But also because, we would probably not want to use this particular URL to give it to our clients and to customers, because this has the disadvantage of potentially changing if we do certain modifications to our serverless template. So it it would be kind of painful if we have to go and tell our clients, hey, you know that the API endpoint I gave you, you're going to have to change it now. So we would maybe like to output a nicer URL than this. And we can go into the details of how that will happen. Reaching the point of hosting. Okay, as mentioned, not the greatest URL there. How about if we could maybe expose it in a custom domain, given that I might already have a domain that I've purchased, or that we want to purchase one from AWS itself, because it can actually do that. So API Gateway actually gives you the opportunity to set up custom domains for an API that you have. And you can also set up different base path mappings, sort of if you wanted to go not necessarily to a root, sort of like example.com, but you would like it to go to example.com/API or I don't know, values in the case of this particular API, if we want to map it that way. You can actually do that in custom domain. But of course, you need to have a registered domain name in order to do that. And you can do this in AWS itself via Route 53, as we'll see, or you can just purchase a regular domain name and use that. And the idea is that, okay, you set up the custom domain on your API, but the custom domain is not known by any DNS server. So if a client goes and inputs that URL in your browser, they're not going to be able to find it. And this is where Route 53 comes in, which is essentially exactly a DNS server. And you can use this with various services, either inside or even things outside of AWS. So you can just point it to various IPs. You can have CNAME records set up in there, whatever you really need. And the cool thing about Route 53 is that being a part of the AWS ecosystem, of course, it's meant to work with other AWS services. And there's a really nice way of setting up basically an alias to other resources like API gateways or load balancers or even other stuff by just setting up a record or multiple ones in your Route 53 in your hosted zone. Cool thing about Route 53 is that you can have just simple routing, just one-to-one. I'm going to route this custom domain to my API gateway, let's say. Or you can do routing based on a client's geographical location. This means that if they're in a certain continent, they will get routed to a resource deployed in a certain zone in an area. And this goes further to sort of country level. So if you're in a particular country, you can get routed to a particular instance of your API. And for the case of the United States, I believe it also goes as deep as state level. You can actually also set up routing based on the latency that a user has to a particular instance. But what we're going to do today for the sake of demonstration really is just to use simple routing. Okay, and for that you might be asking, okay, but what do I need to do this in my template? Well, of course, we're going to have a couple of prerequisites. One is, of course, having a purchase domain, and the other is to have a certificate for your particular domain. And we're going to need to have one created in the same region as our API gateway. I didn't really go into very much detail about regions, but all of the resources in AWS, I should say better, are region split by region, so you won't have all the lambdas that you've created, say in Ireland, showing up in your North America region and stuff like that. And it's better to have sort of resources work together in the same region due to latency and that sort of consideration. What else we'll need to add to our template is the API Gateway custom domain name, base path mapping. So to say, okay, from the API Gateway, where on our custom domain do we want this to map? And of course, a Route 53 DNS record, so it can actually be discoverable by clients in the world. Okay, so let's exit out of the presentation and actually do that. So for this, I'm just going to expand a little bit here our template. I think I forgot to mention that we actually have some IntelliSense support here, so we don't. It is kind of painful to try and write templates by yourself, which is why I'm going to use my handy dandy cheat sheet. And I'm going to explain what's going on here in a second. But you do actually get some IntelliSense. So if I go to properties here and trigger it, I'm hoping you might be able to see there's a little IntelliSense window, and you get to see sort of little properties that can be set up for any particular resource. There's a JSON schema behind this, and just works nicely. Okay, so you can see here that I've added some parameters. These are the domain names and the certificate that we need to have on our API gateway in order to work with the custom domain name. These are things that you will need to set up previously. And the hosted zone ID is sort of an indication of which domain you're pointing to in Route 53 if you're setting it up that way. Okay. In terms of resources themselves, the function doesn't change at all. It remains exactly the same. But we will see that we're adding a couple more resources from what we had before. First one being the domain name for the API gateway. We're saying that, okay, I'm going to have a domain name type resources. And on the property, we're going to give the parameter using a reference to the parameter that we have up here. And on the configurations, we also have to set up the endpoint type, which can be regional or edge optimized. I'm just going to go with regional for now because I don't necessarily need a CloudFront distribution and all the other things that that edge optimized can give you. We don't really need that right now. And for the certificate, again, a reference to the parameter that we are going to give to the template. That's the custom domain. Now, for the base path mapping, of course, we have an API mapping type, which will depend on our two previous resources. And we're basically going to say that the API ID that we get from the function itself will have this domain name and will point to this stage of the API gateway. And if I'm not specifying any other custom routes here, it's just going to go to the root of my domain. We'll see that in a second after we redeploy. The third and final resource that we're going to add is a Route 53 record set, which again depends on some previous resources that we have. We're setting some properties related to the hosted zone and the same domain name that we've used previously. And the record type will be A in this case. You can use A or CNAME for just regular pointing of things, but for A type records, it's actually free of charge. For CNAME, you actually have to pay something, and I think you can set them up in the domain Apex. So you can't set them up in the example.com. You would have to set them up for example.com/something. Okay. We have the target for the alias, so our gateway domain name, and sort of the DNS name that we'll have in the Route 53 console, and we'll look at that when we deploy it. And also in the output section, besides the existing API URL that we already have, I've also added a friendly URL just to make it easier to access, which simply uses the domain name and the Swagger, so I don't have to type that afterwards. Okay, now that we've seen kind of what we're doing, let me actually show you how you can deploy using the toolkit. So I'm just going to right click on my project. I'm going to go and click on Publish to AWS Lambda. I'm not sure how well this is going to show up. It might be a bit small, but I don't think I can zoom you in very much. I'm just going to choose the same stack name that we have previously and the same S3 bucket. And you can see here, I hope, that there is an option to save settings to AWS Lambda tools for future deployments. And we have the specified parameters that you can check, and we're just going to go publish. And if we go here to our stack and refresh, we can see that there's an update in progress that we've initiated in our Visual Studio. You can also see updates right here in Visual Studio as it goes on. While that creates, because it's going to take a little bit of a while, I can also just a little bit of preview on sort of the Explorer that comes with the toolkit. And here you can have various resources that you can access, like S3, Dynamo, all sorts of things, including Lambdas. Just so you know that that's there if you ever need it. And you're gonna have to give it a little second because it's creating new things. Okay, so the update has completed. Great. Let's see what's happened extra since we last were here. Okay, so we've created the API mapping that we specified, and we have the domain name on the API gateway. And if I look here amongst all the other things that were already existing, we also see a Route 53 record set, which is exactly what we specified in the template that we would want to happen. Also in the outputs, you can see now that there's a friendly URL that's nice and friendly. I'm gonna leave that to the end, just build up the suspense to see if it will work or not. I hope it will work, maybe. But first of all, let's go to the API gateway and see what has changed. So in terms of the API itself, nothing much has changed. We're still going to have a proxy that goes to the Lambda and comes back. But the difference is in the custom domain name that we've created, which previously didn't exist. And you can see that this is pointing to a demo.dormenco.net. This is the hosted zone for the dormenco.net domain, which I actually do own. No, you can't have it. And we can also see the API mapping. So I'm going to say that the demo API, which is in the API gateway with the prod stage, goes to sort of the root path. That's what essentially path none means. And if we go to Route 53, I can first show you that I have a registered domain. This I've registered previously, actually a while back. And the reason why you wouldn't necessarily put the registered domain I told you this would happen, so I warned you. I did warn you. The reason why you wouldn't put the registered domain as a resource in your serverless template is because this takes quite a bit of while to create. And you probably wouldn't want to delete it if you delete the stack or things of that nature. So that's why there are certain things that you might consider putting in a different serverless template than your API stacks or application stacks or stuff like that. So I already had that. We can go to the hosted zone that corresponds to this domain. So you can see here, and we can see the records that I already had. The first two records are things that AWS sets up for you, which are basically name servers that will respond to your domain to respond to queries. The CNAME record you see here is pointing to the certificate that I had for my domain. And the last, but not least, little thing is the record that we've set up in our stack that we've just added to point to demo.dormenco.net. And you can see the writing policy is a simple one. The type is A, which is exactly what we wanted. So it looks like everything was created okay. Let's go to the outputs and see if it will run. So you can see I'm on demo.dormenco.net. My connection is secure because I have my valid certificate. It seems to load. And it actually runs. Yay! Congratulations! We have a deployed and hosted API, and with a friendly URL to boot. Cool. So, just a second. Okay, that's kind of the whole flow that I wanted to guide you through tonight. You can have a look at the repo link there for the actual example project, including the serverless template and the slides for tonight. And I've also linked a bunch of resources and documentation from AWS that should hopefully help you in getting started. And yeah, the time for Q&A. Well, we have .NET 5.0. I'm assuming you mean for Lambdas. Currently, there is Lambda support for .NET Core 3.1. And as far as I know, there is an issue opened on the AWS.NET repo, and they're looking into providing support for 5.0, even though it's not long-term support. I believe .NET 6 will be long-term support, but they did agree that it's going to be quite a long time for people to wait until 2021, and probably a few months after it actually comes out. So they're probably going to work on something for .NET 5 as well.
Iulia, I have a question, if I may.
Boy. Oh God, yes.
Are there any concerns that we need to be aware of when we are deploying in this way that is shown us today, basically serverless and using a Linux environment and so forth and so on?
Sure, there's a lot of things to be aware of, including where you store your credentials to access your account. So everything you saw there was me interacting with my personal account, and that means some credentials set up on my local machine, and you need to be careful what you do with them. Even if you have a user that's only used for CI/CD, you need to make sure that those credentials are safe, because if someone takes over them, they could potentially have their way with your AWS user and do whatever they want in your account. Also be mindful of runtimes and maybe think about running tests over a particular runtime. If you're worried that some functionality might be affected, you might be surprised sometimes. There are options to run tests, so to use .NET Test with a particular runtime. That's something to keep in mind as well. And also, obviously, keep thinking if the serverless platform is okay for your particular sort of business need. Is it going to fit with what you need to do? Are there things that are very long running, very costly? Think about, sort of Lambda is cost per processing, I believe. So the more requests you process and the more time the Lambda's running, you need to pay for that. So if your customer is not going to have money to keep up, you might need to consider that. I hope that answers your question.
Yeah. Thank you, Iulia. Thank you.
You're welcome. I can go on. And
we have 2 more questions on the chat. One from Gennady. So some pros for AWS versus Azure for .NET.
Pros for AWS. Well, AWS being in the market for a bit longer than Azure, as we know, might be a bit more mature in certain features. Although I think Azure has definitely sort of got up to speed in recent times, and they have a lot of the basic stuff that you would want, maybe even beyond. Yeah, if you maybe want to have other technologies in your ecosystem of applications, sort of you want to run something on Node.js or Java or other things or Python or I don't know, and you want to have something that's very non-homogeneous in terms of technology, you can always go to AWS and easily go for it. Personally, one drawback that I do find with AWS is their documentation is rather hard to sift through sometimes.
Okay, and we have another one.
Stefan, hey Stefan, do you know if there is a similar library comparable to durable functions in Azure that works for AWS? It's been a while since I've worked with Azure actually in durable functions, so I'm not sure if there is anything, but I can maybe do some research and get back to you. Thank you so much for taking time out of your evening to be here with us. And please keep an eye out on the meetups group for Maxcode, because I know there's some other presentations coming your way in the next coming months. And thank you so much for being here.